Okay, let's do geometry. First, the basics. 180 is a very important number in geometry. It's the number of degrees in a straight line. So if two adjacent angles add up to a straight line, like this, then they add up to 180 degrees. A plus B is 180 degrees. These angles are called supplementary. When two lines cross, the angles on the opposite sides of the vertex, the point of intersection, are equal. It looks like this. X and Y are equal. Now, the sum of the angles of a triangle is also 180 degrees. So that means if you know two angles of a triangle, you can always find the third. Okay, now we're going to look at the kinds of questions that you have to solve involving triangles. Most of these questions involve some combination of sum of the angles of a triangle, supplementary angles, and vertical angles. First of all, what's the definition of a triangle? Well, if you said a figure with three sides, you are correct. So let's just detour for a minute to go through the names of the other polygons. Now, a polygon is a figure with some number of sides. A four-sided figure is called a quadrilateral. We will study them soon. A five-sided figure is called a pentagon, and a six-sided figure is a hexagon. You might be asked a question that requires you to know the sum of the angles of various polygons, and the formula for that is 180 times n minus 2. There it is on the screen. 180 times n minus 2, where n is the number of sides of the polygon. Now, if you forget this, just start with a triangle and add 180 degrees for each side that you add. All right, two more things, and then we'll get back to triangles. The sum of the external angles of any polygon, no matter how many sides it has, is 360. So here's a pentagon. The external angles add up to 360. Now, a regular polygon is defined as one with all the sides, and therefore all the angles, equal. Okay, let's get a couple more definitions out of the way. What's the perimeter of a triangle? Well, I'm sure you know that the perimeter is the distance around the outside of the figure. It doesn't matter what kind of a figure it is, except the perimeter of a circle has a special name. It's called the circumference. Well, we'll get to circles later. But just remember, the perimeter is the distance around the outside. The most general form of a triangle has no angles that are equal, no sides that are equal, and no right angles. A right angle, you remember, is 90 degrees. Okay. This general triangle is called a scalene triangle. Most triangles on this test are not scalene. They're usually special in some way. Okay, the first way that a triangle can be special is to have two equal sides. This special triangle has a name, and that name is isosceles. There are a lot of isosceles triangles on this test, so look for them. Here's why they use them a lot for questions. If you know one angle of an isosceles triangle, you can find the other two. That's because the sum of the angles of a triangle is always the same, 180 degrees. So, here's rule number one for isosceles triangles. The angles opposite the equal sides are equal. Okay, let's try a couple. Suppose one of the angles of a triangle is 30 degrees, one of the equal angles. What are the other two angles? Well, One other angle is 30. And the third angle has to be 180 minus the sum of these two. 30 and 30 is 60. So that last angle has to be 120 degrees. Now what if we only know the unequal angle of a triangle? Suppose the unequal angle is 50 degrees. Well, we know that the sum of the other two angles has to be 180 minus 50. That's 130. And those other two angles are equal. So they're 65 each. When you see an isosceles triangle, think how you can find one of the angles, and then you'll have them all. You can get one of the angles by vertical angles, or maybe by supplementary angles. But all you have to do is find one. Okay, let's try a couple of examples. Here's a figure where you know an external angle of the triangle, 130 degrees. This is an isosceles triangle. These little hash marks mean that those two sides are equal, so the opposite angles are equal. How do you find the angles of this triangle? Well, the angle that's supplementary to 130 degrees is 50 degrees. 130 plus 50 equals 180. So one of the equal angles of this triangle is 50 degrees. The other equal angle is 50 degrees. 100 subtracted from 180 is 80. So the unequal angle is 80 degrees. All right, let's try a different example. Here's a triangle where you're given this angle over here, which is 20 degrees. Now, how would you find the other angles of this isosceles triangle? Well, you see that 20 degrees is a vertical angle with the unequal angle of this triangle. So that angle is 20 degrees. Now, how do you find the other two? Well, you subtract 20 from 180, which is 160, and you divide that by 2. So each of the other angles is 80 degrees. Okay, let's move on now to even more special triangles. The first one is one in which all three sides are equal. Do you know what this is called? Yes, it's an equilateral triangle. And because a triangle with equal sides also has three equals angles, it's also called equiangular. To find the measure of the angles of an equilateral triangle, all we have to do is divide 180 by 3. And it is worth remembering that the angles of an equilateral triangle are all 60 degrees. Okay, let's move on. More specialization. Right triangles. These are triangles in which there is one 90-degree angle, and that is denoted by this little box. What makes these so special? Well, for one thing, they occur a lot in nature and in civilization. The corners of a room, for example, or a table are usually right angles. But more important, they occur on this test a lot. Okay, we have to stop for a couple of definitions. In a right triangle, the side opposite the right angle is called the hypotenuse. The other two sides are usually called legs. Since right triangles make such good subjects for test questions, we're going to spend some time studying them. Partly they do this because there's a special relationship among the sides of a right triangle. This relationship is probably the most famous one in all of geometry, and it is called the Pythagorean theorem. Okay, if we call the sides of a triangle A and B and a hypotenuse C, the Pythagorean theorem is a squared plus b squared equals c squared. That means if you know two sides of a right triangle, you can calculate the third. Simply put the two numbers you know into the equation and solve for the third one. Here's a warning. Be careful to put the measure of the hypotenuse in the C place. Okay, let's try it out. Suppose two legs of a right triangle are 5 and 12. What is the hypotenuse? Well, 5 squared is 25. 12 squared is 144. 144 plus 25 is 169. Now, we have 169 equals C squared. How do we solve this? Well, we take the square root of both sides, because the square root of C squared is C. This is the general rule for squares and square roots. If you have something squared and you take the square root, it's just the something. Same the other way around. So C is equal to the square root of 169, and that's 13. Okay, let's try another one. Suppose the hypotenuse of a right triangle is 17, and one of the legs is 8. Well, now we have the equation 17 squared equals 8 squared plus b squared, the other side. So now we have to subtract 8 squared from both sides of this equation, and we get 17 squared minus 8 squared equals b squared. If you do that on your calculator, you're going to get b squared equals 225. And when you take the square root of both sides, you have b equals 15. Okay, by now you're probably thinking that this is a lot of calculating. You have to square two numbers, then you add or subtract them, then you have to find the square root. And here's where you can take advantage of the fact that the people who make this test are confined to asking questions that only take about a minute to solve. Normally, they don't want you to have to spend your time finding a square root that's a decimal and then working with a complicated decimal number. They usually want all the sides of a right triangle to be integers. And remember what an integer is. It's a whole number. Okay, now, it just so happens that there are very few sets of 3 integers that satisfy the Pythagorean theorem. You've already been introduced to a couple of them in those 2 examples. Here's a complete list of the basic triplets up to about 40. Now these are called Pythagorean triplets, and the 5 basic ones are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25, and now one that they've just started to use, 9, 40, and 41. That's it, just those 5. Gets you up to hypotenuse 41. Now, any 3 numbers that are the same multiple of one of these triplets is also a triplet. So you should really be familiar with the multiples of 3, 4, and 5. They are 6, 8, 10, 9, 12, 15, 12, 16, 20, 15, 20, 25. I'm sure you can do several more on your own. However many of these you can memorize will help you. If you learn them, you'll be able to simply write down the length of the third side of most right triangles. Okay, a word of warning now. Always make sure that the hypotenuse is the longest side of any triplet. Sometimes they'll try to trip you up and give you 2 numbers that are not part of a triplet because the hypotenuse is in the wrong place. For example, they might tell you the legs of a right triangle are 4 and 5. This is not part of the 3, 4, 5 triplet because 5 has to be the hypotenuse. Actually, the hypotenuse of this triangle is the square root of 41. Okay, now we're ready to talk about triangles that are really special. and there are two of them. They appear in nature sometime, but more important for you, they come up often on this test. The first special triangle is the isosceles right triangle. Can you figure out what the other two angles of this triangle are? If you can't, go back and review where we talked about isosceles triangles. Well, I'm sure you can. You know one angle is 90 degrees, so the other two must add up to 180 minus 90, which is 90. And they have to be equal, so they each have to be 45. We could do the algebra, and that just involves applying the Pythagorean theorem. But it is much better for you, for the purposes of this test, to memorize the relationships among the sides of the two special triangles. So for the 45, 45, 90 triangle, if the legs are length x, then the hypotenuse is x times the square root of 2. And if the hypotenuse is y, the legs are y divided by the square root of 2. That's all there is to it. The square root of 2 goes between the legs and the hypotenuse. One reason this triangle is so important is that when you draw the diagonal of a square, you get two of these 45, 45, 90 triangles. And that comes up quite a bit in problems on the ACT test. Okay, let's look at an example of 45, 45, 90 triangle. Here's one with side of 6. Now, how can you calculate the hypotenuse of this triangle? Well, apply the rule. It's just 6 times the square root of 2. Let's take one where we know the hypotenuse. Say the hypotenuse is 8. Then the side is 8 divided by the square root of 2. Now let's do a little algebra here, because normally you don't want to leave square root of 2 in the denominator. So to get the square root of 2 out of this denominator, what do? Well, the best thing you can do is multiply both numerator and denominator by the square root of 2, because square root of 2 times square root of 2 is just 2. So then we would have 8 square root of 2 divided by 2, which is 4 times the square root of 2. So when you do this operation of finding the side of a 45, 45, 90 triangle, you will get a radical in the denominator. Normally you don't want to have a radical in the denominator, and you won't want it for the final answer. But don't do this calculation right away. See if something else will happen so that the square root of 2 either cancels or moves, or something else will happen to it. So in general, don't do any extra work on this test. Do the work when you have to. Okay, the second very special triangle has angles of 30, 60, and 90 degrees. This one's a little harder, but not too much. If the shorter side, the leg opposite the 30-degree angle, is x, then the hypotenuse is 2x, and the longer leg is x times the square root of 3. Just like we had with the 45, 45, 90 triangle, if the long side is y, then the short side is y divided by the square root of 3. And then, of course, the hypotenuse is 2y divided by the square root of 3. It will be worth your while to memorize these relationships. This triangle comes up often in connection with equilateral triangles. If you draw the height, and we'll discuss height in a minute, of an equilateral triangle, it splits the triangle into two 30, 60, 90 triangles. Here's how that works. Here's an equilateral triangle. All of the angles are 60 degrees. So when we draw this vertical line, which is the height, the two triangles that it makes are 30, 60, and 90. Okay, so just look for these triangles on the test, and here's a clue. If a problem has a geometry problem with triangles, has a square root of 2 in it, then there's probably a 45, 45, 90 triangle somewhere. And if there's a square root of 3, look for a 30, 60, 90 triangle. Okay, let's look at the area of a triangle. We will examine areas of other figures later, but the area of a triangle is very important, and you must know this equation. Area, A, equals 1/2 base, B, times height, H. Okay, let's try it out. Here's a triangle. This is one time when they may use a scalene triangle, because it doesn't matter what you use for the base. The height is defined by the distance from the opposite vertex to the base. Okay, so look at this triangle. Here's the base. Here's the height. The area is 1/2 base times height. Okay, suppose they give you this problem. Area of a triangle is equal to 30. The base of the triangle is equal to 10. What's the height? Well, if you get this kind of a problem, simply write down the equation. Area equals 1/2 base times height, so 30 equals 1/2 times 10 times the height. I'm sure you can solve that. 1/2 of 10 is 5. 30 divided by 5 is 6, so the height is 6. Remember, you won't get a reference sheet for this test, so you must know this formula for finding the area of a triangle. Now remember that the base can be any side of the triangle, and the height is simply the perpendicular distance from the opposite vertex to the base. Okay, these are big words, but it's really simple. You saw it in this example. The opposite vertex just means the corner that is opposite the base, and then you draw a line that makes a right angle with the base, perpendicular. Okay, one more definition. The height is sometimes referred to as the altitude, so look for that. They could use either one. Okay, when you see a problem that involves finding the area of a triangle, ask yourself, what's the best choice for the base? Okay, fortunately for you, a lot of the triangles that you'll be asked questions about are right triangles. Why is this good for you? Well, it's easy to find the area of a right triangle. Since the legs are perpendicular, they make a perfect base and height. So the area of a right triangle is just 1/2 times the product of the legs. Let's do an example. Here's a right triangle. The legs are 3 and 4. And of course, you know the hypotenuse is 5. And the area is 1/2 times 3 times 4, so the area is 6. Area of right triangles is very easy to find. Okay, there are a couple of principles about triangles that are useful for this test. The first is a shortcut, and the second is actually sometimes used as a trick question. So let's go over them. Here's the useful fact. An external angle of a triangle is equal to the sum of the opposite internal angles. So using this, you can cut out a step in your computation. Let's take a look. If you have a triangle where your external angle is 130 degrees, the two opposite angles are 60 and an unknown angle. Well, you could find the unknown angle by finding the supplementary angle to 130 and then finding x by sum of the angles of a triangle is 180 degrees. But it's easier to do it by this principle, which is 130, the external angle, is equal to x plus 60. So then you can see that x is 70. Okay, here's the trick. Don't let them fool you with this trick. Any two sides of a triangle have to add up to more than the third side. Somehow it's easy to forget this. So for example, if all the sides are different integers and you're asked if one side of a triangle is 8, what is the smallest possible sum of the other two sides? Well, of course, you know it's 9, but sometimes they present the problem in a tricky way, and it's easy to forget this rule and think, oh, it's 1 plus 2. Okay, so be on the lookout for that. All right, before we conclude this section on triangles, I want to caution you to be sure to read the question carefully. Well, we've said this before, and the corollary, of course, is don't anticipate the question. Actually, the most commonly anticipated question, wrongly anticipated, is expecting that a geometry question will ask about area. I don't know why this is so, but students often assume that a question will be about area when it's about perimeter. Read the question, answer the question.